So, hello students. Today's class will solve a simple problem. So, this is a problem statement. A sample of rice husk is to be used as fuel in a biomass combustion plant. The ultimate analysis and proximate analysis of the rice husk have been carried out in the laboratory. Determine the higher heating value. We call it as HHV of the husk on a dry basis and on an as received, that is wet basis, using Dulong's empirical formula. And the data is given based upon the ultimate analysis and proximate analysis. So remember, the ultimate analysis, it is on dry basis. Okay. So carbon is given as 38%, hydrogen 5%, oxygen 36%, nitrogen 0.5%, sulfur 0.1%, ash is 20%. And from the proximate analysis, moisture content is given as 12%. So assumptions are Dulong's empirical formula is applicable for biomass as well as coal. The ultimate analysis values are on a dry, ash-free basis and are expressed as mass fractions, not percentages. When substituted into the formula, the ash component does not contribute to the calorific value and is therefore not included in Dulong's formula. Moisture is uniformly distributed throughout the biomass sample. These are the assumptions. So first I write that Dulong's formula, which is giving the HHV on dry basis, which is equal to 33.83 times C plus 144.3 times H minus O by 8 plus 9.42 times S multiplied, right? And we also have to use to find the HHV on wet basis moisture correction formula. So HHV on dry basis is given by, wet basis given by HHV on dry basis into 1 minus MC by 100. So we substitute all the given data 33.83 into, as per the formula you have to give C value. So C is given as 38%, which is 0.32 mass fraction. So that is substituted. Likewise, all the values as per the formula, the data we substitute. So upon simplifying, we get 13.586 megajoules per kg. This is on HHV on dry basis. So now we are supposed to find HHV on wet basis. So this is the formula. So we substitute 13.59, which we found earlier, 1 minus. Remember here moisture content we have to substitute as a percentage. Okay. So 12 by 100. So HHV on wet basis is 11.96 megajoules per kg. So, and these are the we'll present the results. So HHV dry on dry basis, it is 13.59 megajoules per kg, and as received, right, that is wet basis 11.96 we found. So therefore, what we understand from this is, so typical coal will have a HHV value of 25 to 35 megajoules per kg. Rice husk at 11.96 megajoules per kg is approximately 40 percentage of coal's energy density. The 12% moisture reduced the HHV from 13.59 to 11.96 megajoules per kg. A loss of 1.63 megajoules per kg, about 12%. So this demonstrates why biomass pre-drying is critical before thermochemical conversion. So for that reason only, this problem is explained here. Hope you understand this problem. Thank you.